You're listening to ChainLeak, the crypto news podcast with your host, Joshuwa Roomsberg. Follow and subscribe today.
Welcome to the ChainLeak podcast. I'm your host, Joshuwa Roomsberg. Today's episode is about Quai Network, Decentralized Multi-Chain. Today's guest, Dr. K. Welcome to the show, brother.
Thanks for having me. Glad to be here.
All right. So for the listeners who haven't heard about Quai Chain, give them a quick introduction.
Yeah. So Quai is meant to be a scalable proof-of-work, EVM compatible blockchain. So think 50,000 transactions per second. And we do this through this novel architecture, this novel consensus mechanism we call POEM, but on a proof of work system. So we sort of get all the decentralization characteristics of Bitcoin, but with a scalable, high throughput system that can actually function as money. And that's really one of the primary pieces of Quai, is that we're trying to build something that can truly replace like the dollar denominated world.
Okay. Now this is a proof of work network with parallel processing and EVM compatibility. Let's go into each one of these aspects and explain the benefits of each.
Yeah, so really the initial pieces of Quai was driven through sort of the concepts of how you scale traditional systems. And if you think of what is most akin to a blockchain, in some ways it's a database, sort of at its first level. But at the second level, right, you need consensus around that database so you kind of can all agree on what's in this decentralized database at once. So what we figured out initially was that we could use the concepts of sharding as well as subnetting to increase the throughput and the performance of a blockchain. But the way that you can do that in a proof of work setting, so you can shard state, i.e. make shards of different transactions and data, without sharding the work, is this concept of merge mining. And so what that ends up getting you is it gets you the ability to have sort of like many chains running in the system that are all merge mined together, so they eventually all reference each other. But it allows you to have parallel processing in that. So every chain is kind of running independent until it references one of the other chains, at which time they have to become consistent with each other and come into consensus. But in the meantime, they can all just sort of run independently. And that's where you get this concept of parallel processing, which is each shard is running independent of the other shards. So you can sort of have really high throughput.
Okay, now with the shards, are these shard networks considered the main chain still, or are they independent as an alternative blockchain themselves?
Yeah, so that's a great question. So to get this to sort of work, we actually had to come up with a new consensus mechanism we call POEM, or proof of entropy minima. But that mechanism allows us to sort of always choose the leader of the system. So there's many sort of potential chains that are leading the system, but only one of them is actually leading at any point in time. And we can choose that one deterministically using POEM. And so because the chains are all merge mined together, their consensus is all shared and their work is ultimately all shared. And the instantiation of the EVM and what they're doing is all the same. So it looks like one system from the user's perspective. So the user doesn't really see the independent chains. It just sees the Quai network. And they interact with it via addresses, and those addresses sort of are sharded into each one of the chains. But from the user's perspective, they're not necessarily needing to be aware of it. If they want to send money in Quai, they just put an address in and put an amount, and the money sort of goes where it needs to go. If they want to do a contract interaction, it's the same sort of thing, but like sort of encoded in the addresses, encoded in the contracts, encoded in the transaction hashes is this sharding information. But the user doesn't have to be aware of it. They just use it like an EVM chain, and it looks like an EVM chain to them. And then under the hood, it's figuring out which shard to use, how to use it, how to transfer state between the chains, et cetera. So it's very transparent from the user's perspective. They're just like, I want to do a transaction. give me an address, and then they're guaranteed high throughput.
Okay, now speaking of addresses, something I realized about Quai Network that's different than other EVM compatible chains is the beginning of the wallet address. Is there a reason why you changed that to where it's not just 0x and a bunch of numbers? It's very specific at the beginning of these wallet addresses. What's the reason behind that?
That's a great question. So that's actually how we're encoding the shards into the addresses. So the first two bytes in the address tell you what shard that address exists in. So a 00 address sort of exists in the 00 shard. A 01 address exists in the 01 shard. The cool part is because you put that into the address itself, the user doesn't need to know what shard they're in or they want to send to. They just need an account and that's it, right? So that's kind of how we hide the sharding from the user is we do the encoding and the sharding in the addresses themselves.
In the address itself, yep, that's cool.
Which is very different from there's other sharded. There's a couple other examples of. I think there's one other example of really a sharded work-based system, which is Kadena. But what they did is they basically said every address is available in every shard.
Every shard, yep.
Right. So as a user, you actually, to send money, you need 4 pieces of information. You need to know what address you're coming from, what shard you're sending those funds from, what address you're going to, and what shard you're going to. So instead of just having like one thing, you have to have 4 things, which makes it very complicated and sort of burdensome for the user.
For new users to the industry, they're not trying to collect 4 types of information just to send a transaction. So by you explaining that, Kadena, you said it was, people at the end of the road are not going to use Kadena for everyday use. Well, because of that simple fact of four types of information is needed to send a transaction.
Well,
that's mind-blowing.
It's also actually very interesting, too, if you look at sort of the more popular uses of Ethereum. So right now, when, say, you want to send USDT, how much information does like someone have to give you now? It's more than just an address because you're going to ask the asset and you're going to also ask the chain. So then as a user, you're technically saying, okay, I have USDC. I have USDC on Base or on Ethereum. Right. And you're requesting USDC on Base. Okay. Yep. So now I have 4 pieces of information again, right? Because I have an address and I have a chain, right? So it's the same thing as Kadena, and it's also just as inconvenient. And then to do the swap, I'm going to pay like $6 or $7 because I got to swap not just USDC to Base. I also have to swap ETH to Base so that once it gets there, I can send it to you.
Right. That's... From my perspective, when I'm doing business transactions, I'll say, here's the address you can send on any of these 4 chains. I try to simplify it that way, but at the end of the day, you still need to know what chain it's coming on, the amount, if there's anything different between the chains. So yeah, if the liquidity's there, there's a lot to worry about when you're going between chains like that for sure.
Yeah, I mean, we put up with it, but is that really like something that's going to scale? So if we actually get real people using this for real business, how many different forms of Base do we need? You're going to have like an Arbitrum, you're going to have an Optimism, you're going to have a Base, you're going to have a Binance, you're going to have like 27 different things, right? And so your list is going to be 27 different things long.
Types of Ethereum, yep.
Yeah, types of just like different forms of Ethereum, and it's effectively a sharded system, right? But it's like right in the user's face. So the cool part with Quai is because it's all the same system, it's highly integrated, we can create the 27 versions as just independent chains within Quai, but they all look identical and they're all sharded across this address space. So then from a user perspective, it's just give me your address and tell me the amount and I'll send you the money. And so we don't have to orchestrate that mentally.
I'm thinking about for exchange wallets. Would an exchange use one shard for all of their customers, or would that exchange have multiple shard addresses for their customers on Quai Network?
They could do whatever they want. If they want to manage everything.
What would be most common?
Well, I mean, it really depends on the exchange. I would say that from an exchange perspective, they would probably just put everybody in a single shard as long as there's enough throughput in that shard. If they're kind of doing a lot of transactions there, or there's like congestion and they get sort of bad pricing, they may want to use a second shard that has better pricing, right? But it's pretty simple from their perspective though, because they sort of have like a omnibus account, and all of the sort of addresses in that account, they can always send to any of the addresses at any point in time. So they don't have to have like, and they could still just have one omnibus account too. They could literally put all of their funds in one shard. And then if they need to sort of like send to other shards, they just send it. It's not a big deal. So, they don't need to sort of think about it too much either. Just like the users don't really have to think about it too much.
Moving away from exchanges into wallets, how hard is it for wallet companies to implement Quai technology? I'm thinking I'm a partner with Tangem and SafePal. If they wanted to integrate Quai Network, what would be the process? Would the wallets choose a specific shard for their wallet provided customers, or would that be interchangeable? What would that look like?
Yeah, that would look interchangeable for them as well. I mean, in terms of integrating, we have an SDK that sort of abstracts all of this information from the application. So you just really need to say like, what, you want an address and you want an address, just tell us what shard you want it in and we give it to you. And then if you want to send money, you can send money to any other shard. So it's not like a huge sort of decision, sort of what shard you're going to operate in. What you're ultimately going to want to do is, as people are creating new wallets, you're going to want to kind of spread them out based off of like where the cheapest pricing is, right? So like there's sort of a balancing mechanism in the shards, which is if one shard sort of gets overcrowded with too many users doing too many transactions, while the other one doesn't have a lot of transactions in sort of the crowded shard are going to be a little bit more expensive. So as a wallet provider, you should just kind of always be assigning people into the cheapest shard at any given point in time.
That makes sense. I'm thinking for Tangem as an example. For the Tangem wallet, would they be able to have the 00 addresses for all of their customers? But you're saying it would be more beneficial to be interchangeable based on what's getting the best rate and what's the best performing shard on the network.
If I was setting up a new wallet, I would just say, what is the cheapest shard to run in? And that's where I'd put my money.
Okay. So for a new customer that creates a wallet today, and say somebody creates a wallet tomorrow, mine might be 00 right now, and that wallet provider can give a 06 tomorrow for whoever's creating the next wallet?
Yep, that's right.
Okay, that's pretty mind-blowing. Now, you mentioned earlier 50,000 transactions per second. Is that the maximum on the network? Is that a minimum? What's the max transactions per second that Quai can handle?
So we kind of just advertise 50,000 as like the number, but it technically could go much, much higher. I would actually estimate the maximum, given the current status of the system, to be upwards of 250,000 TPS. But it could even be higher than that, because we have this concept of subnets. So as the number of shards increases, there's sort of this incentive for the miners to self-organize into more sort of network optimal subnets to reduce latency. And they'll just get better mining profits by doing that. So if that happens, you'll as the number of shards increases, each shard actually becomes more performant. So you'd expect the TPS per shard to actually keep increasing. So potentially it could be closer to 1 million TPS based off the current programming limits than 250,000. But technically, because you can shard, it's not necessarily a truly bounded quantity. There is a trade-off that takes place, which is the number of shards that you have in the system. You have this concept of respending time. Okay, so if you do any transaction, if it's an intra-shard transaction, you'll get a confirmation in 5 seconds, potentially 8 seconds, but you'll be able to instantly respend it once you have it. If I'm going inter-shard, the number of shards that I have like affects this resettlement time, which means you'll get a confirmation in that 5 to 8 seconds still, but you won't be able to respend it for some period of time depending on the number of shards. So if we say had like 100 shards and we were doing 100,000 TPS and we were sort of used as money globally, would be kind of the statement if you're doing 100,000 TPS. Your time that you would potentially wait, worst case, to be able to respend money that you receive is 60 to 90 minutes. So you'll still know that you're getting the money in 5 seconds. You just won't be able to respend it for an hour to an hour and a half. So that's actually the bound in the system. You could technically have 1,000 shards. It's just that number might go to 5 hours instead of an hour. Right.
Now, how do you decrease that time for that respend? Well, is there any way you could get that down from an hour down to 5 minutes or 2 minutes?
Well, so there's two statements. One is we don't actually see that as the most important property in the system, because if you actually look at sort of like capital efficiency in the current world, right? If you take a credit card payment, you technically don't get all that money for up to 180 days. You don't see any of that money for 60 days. So we're taking what we're currently living in this quote unquote electronic payment system with Visa, MasterCard, and we're compressing it from 180 days down to an hour, right? So like the number of times you have somebody that's like, I need to send something and immediately respend it is like very small. But there are ways around that too, which you can kind of do atomic swaps between the shards. So if there is demand for sort of like instantaneous respending, you could do that. You'll need a liquidity provider and you're going to have to pay like a percentage for that service. Maybe, because it's competitive, you might pay like 20, 30 bips, but you'll pay some amount of money for the convenience of being able to instantaneously respend. But you'd be able to respend it in say 15 seconds if you use an atomic swap across the shards.
Well, I'm thinking sometimes I send from an exchange to a personal wallet in USDC. And then 15, 20 minutes later, I got to run to the bank and pull that out and put it in the bank account. So for that time frame, sometimes I catch myself sitting in a bank parking lot for an hour waiting for all these transactions to move. And I get the aspect that you're thinking about, but I might be a unique perspective as well.
Yeah, no, and in terms of like people who want to be like very capital efficient, they might have a better opinion or like a more ardent opinion about what shard they want to be in. So in your case where you're going to send it from an exchange to a custodial wallet to a bank, you might be like, well, what shard is my bank in? And so when I send it from the exchange, I'm going to send it to the same shard that my bank is in, so I don't have to incur that resettlement time.
That makes sense because when I use the USDC, I have to move it from an exchange back to my personal wallet, then to the wallet I have connected to a card where I can pull the money out of the ATM. It's like 6 steps I got to go through. And sometimes, as an example, when I'm using Ethereum, that could take 45 minutes for an Ethereum transaction to go through, and I'm stuck waiting.
What I would do if that was me is I would make sure my exchange address was in the same shard as my personal wallet account, which was in the same shard as my bank card's account, so that when I do that transaction,
all three is fluid.
5 seconds for each one.
See, now that'd be wild. Now, you said 5 seconds. Is that the confirmation and respend time?
If you're in trust shard. So
in the same shard?
If you're in the same shard, that's your confirm and respend time, yeah.
Okay, so the confirm and respend time is only expanded when you're going between different shards?
That's right. That's
okay.
Right. And when I say if we have 100 shards and you're talking an hour to 90 minutes, that's a worst case. If you're kind of like closer together, it'll be faster than that. It's like if I'm like in the furthest apart shards, do I like have that going to happen?
A few minutes ago, you mentioned subnetworks. Let's go into subnetworks and braiding and how that affects the network.
Yeah. So the concept of a subnet is actually one that has a relationship to geography, or the sort of, as you would say, the topology of the internet itself. So what ends up happening is when a miner is mining, if we look at a traditional mine system, the only thing they're worried about is how to maximize the reward per hash.
Yep.
But because they now have also a decision of which shard they want to mine, there's information in that decision that will help them maximize their reward, which is they want to pick the shard which is least latent to them. So if we do like a simple example, and we kind of have two shards, and the shards are generally like Asia and like generally the Americas,
Yep.
in terms of like who's participating. If I have hash rate that I'm bringing online as a miner in West Texas, I'm going to look at that. I'm going to be like, well, most of the shards that are running 0, 0 are in the Americas, while most of the shard or the nodes running 0, 1 are in Asia. So I'm going to pick to like go mine in 0, 0 because the nodes are closer to me. And so my blocks will get to them faster, and I'll be less likely to produce an uncle, which means my rewards will be higher. So I'm not just looking at, what is the reward per hash in Asia and America. I'm also looking at, what nodes are like geographically and time, like in terms of latency of propagation, closer to me, so that I can make more money. So you're actually trying to optimize the network and how we organize ourselves on the internet to sort of create subnets. So the miners will just self-organize into these subnets, which will make the total system more performant, because as they want to make this decision to increase their revenue by choosing peers that are closer to them, they're actually improving the aggregate performance of the system and the aggregate throughput of the system. So that's what I was saying earlier in terms of, as you create more shards, because they're incentivized to organize into these subnets, the throughput actually goes up as the number of shards per shard goes up as the number of shards go up. So maybe if you have one shard, we could do say 600-700 TPS in a shard, but then we go to 10 shards, you might be doing 2,000 TPS in a shard. So there's actually this like sort of exponential throughput factor that happens with the number of shards. So the more shards you add, not only are you adding more throughput by adding a shard, but you're actually increasing the throughput of each shard because each one gets more performant.
That's so mind-blowing. There was so much information you just put out right there, and I'm trying to wrap my head around it. You're saying the closer the nodes or the subnet, okay, so let's run it like that. The closer the subnet is to my person is the quicker the transaction would go through. Whereas if I sent the transaction through to China, it's going to be a delay and have latency like you just mentioned, and it might be delayed. Whereas using the closer subnets, I have the ability for the transaction to go through faster. One, from a trading perspective, if you look at the trades inside an exchange, you might be the faster person because you had less latency and you were closer to that subnet versus sending across the world to another country. Is that what I'm understanding?
Yeah. Yeah. And both from a transaction perspective and from a block production and propagation perspective. So both the users would get faster transactions, and the blocks as a miner get faster sort of propagation. And right. So like if I mine a block, there's this process where, if someone else mines a block, as my block is sort of propagating through the network, we get this, sort of fork. And only one of these blocks is going to become the true block, and the other one's going to get uncled. So what I want to do is I want to make sure that when my block is propagating in my shard, it's doing it like very efficiently. So if I can minimize the time it takes to propagate, I can maximize my revenue. So, and the same thing is true with transaction as well. So like if you're doing a transaction or you're producing blocks, you're going to want to do it with peers that are closest to you. And by doing that, you'll get the fastest propagation of transactions and inclusion, and you'll also get blocks which are most likely to become, the canonical chain, and maximize your revenue.
Now, you guys also have the ability for EVM compatibility for developers building on Base and Ethereum to bring their dApps onto the Quai network. Let's talk about that a little bit, and what are the benefits as a developer building on Quai network versus Ethereum or Base?
Yeah, great question. So the cool part is we're EVM compatible, so people can come over with like Hard Hat and the normal sort of Solidity development tool chain. They can use tools like WAGMI and Graph and so on and so forth. So they can pretty easily port most applications over with very minimal sort of changes. From a developer perspective, right? There's so much work that's been done developing applications on the EVM and tons of contracts that have been audited and gone through sort of multiple generations of development and hardening. That's a really valuable thing. I will say though, specifically with like Ethereum, one of the problems that applications developers have always suffered from is if you get sort of popularity of your application, one popular application can like bring the chain down in terms of its ability to do transactions at a reasonable rate. Right. And I remember the first time this kind of happened was CryptoKitties. If you're familiar, but basically,
Yeah, no, for sure.
Someone made breeding cats. So it was an NFT project, but it was a breeding NFT project. So like the NFTs could sort of have babies, I guess. But it became super popular, and it basically, sent transaction fees to $50, $100, and completely sort of, hamstrung the chain. It also then hamstrung sort of the adoption of CryptoKitties and its ability to grow because no one could actually sort of trade them
Use the network. Yep.
Yeah, amount of money. So the cool part with Quai is because we have high throughput and we can add shards as things become popular and as demand increases. Applications will still have access to the network because
they could move to the next shard.
So yeah, they can move to the next shard because what happens is the network actually figures out like when it needs a new shard, and it does this by measuring the uncle rate. So as the uncle rates go up, it's basically telling the system that there's more sort of demand for transactions than there is supply, and if it can't sort of expand the block gas sufficiently without increasing the uncle rate, it knows it needs a new shard. So once the uncle rate kind of goes over 20%. The system kind of locks in an expansion and adds a new shard, and then that increases the aggregate throughput of the system. So if you have a popular application, you're not going to get sort of locked out of growth. The system is going to grow with your application. Another way to put that is, when you do a transaction in Quai, a simple transfer is something like a half a cent today. It'll be a half a cent tomorrow, and it'll be a half a cent in 5 years. Regardless of growth, because it can always grow with the amount of demand.
You just mentioned that you could bring over dApps from other EVM compatible chains. Do you have the ability to bring over assets from other EVM chains, whether natively on chain or using a third-party bridge? Is it possible to bring Ethereum onto Quai, Bitcoin onto Quai, XRP onto Quai? Is it possible to bring native assets onto the Quai network?
Yeah, so you can move assets to Quai currently through a number of centralized exchanges. We're integrated with Gate, MEXC, as well as a non-KYC aggregator called SwapSpace. We also recently announced that we got added to Kraken's listing roadmap. So that'll be, a good US listing with a tier 1 exchange where you can just buy Quai with your USD. In terms of the native stuff, we have a partnership with Portal of Bitcoin. We're ready to go. They're still kind of in testnet, but hopefully within the next few weeks or months, they will enable bridging of BTC over to Quai. And we also have a partnership that we will soon announce with a EVM bridge provider as well, which would get you your native assets from Ethereum and Base.
You guys are big on, security and decentralization and censorship resistance from a personal perspective. What is your take on security and being decentralized in the blockchain space?
Yeah, I mean, from a practical standpoint, decentralized systems ultimately become the most secure systems. So if you look at, Bitcoin after the first couple of years, or even Ethereum, once you kind of get over your first couple bugs, they become the hardened systems that are always online and just work without flaw. And that's the sort of property of decentralization. But the other property that I think is like very important is, and why decentralization is important, is because we're fundamentally like shifting towards a digital world, right? With the introduction of smartphones, and everyone sort of spending hours per day on those smartphones, and when they're not on the smartphones, they're on the computers. Like we're clearly moving towards a digital world, and there's really sort of like two paths that I see taking place. One of those paths is where we have a CBDC, or central bank digital currency, issued. And with that, likely, a surveillance state with sort of a high degree of fascism and a low degree of individual freedom, where every transaction is monitored, could be censored for, political wrongthink, or say buying too much meat on Wednesday. So that's sort of one pathway that we can go down as we go down towards this inevitable digital world with digital money. Or we can take one that's decentralized, one that's censorship resistant, one that is unconfiscatable, one that has sound money characteristics, so it can't arbitrarily be inflated away, one that has cash-like privacy properties, so on and so forth. And if you go down that road, I think you go down one where we actually enhance individual freedom and liberty, even though we become more of a digital society with digital money. And so fundamentally, the reason decentralization is important to us is not just from a security perspective, but also from a liberty perspective, in trying to build money, which will give rise to a moral and just society.
Okay, so to close out the interview today, let's talk about the testnet and anything you've learned about the network throughout the testnet phase and the transition into what's next for Quai Network.
Yeah, I mean, we learned a ton, during the testnet phases. We did 4 of them. We learned sort of how to optimize the peer-to-peer layer. We learned how to work with shards, and we learned that we should have like the minimum number of shards at any given point in time as demanded by the system to sort of get the best security and the fastest finality of transactions. There's probably 100 different lessons that we learned during the testnets. And mainnet, right, happened at the end of January. And so the network, the mainnet, has been live for 3.5, 4 months now. And things have been going relatively smoothly. We kind of, spent several years doing the test nets, because the goal of a blockchain is to be a protocol, really. And so you don't want to change kind of, the economic properties of that protocol from out of under users, right?
Yeah.
So we spent a lot of time to make sure that economically it was like well developed. And so sort of we've done releases to sort of fix bugs here and there, sort of quality of life issues. But, the goal here is not really to change the system. It's been built, it's been tested, and it's ready to go to scale. And so that's why we did so many test nets and learned so many lessons.
Awesome. Well, this has been Quai Network, Decentralized Multi-Chain with Dr. K. Thank you for being here, brother.
Thank you for having me.
The Crypto News Podcast with your host, Joshuwa Rumsberg. Follow and subscribe today